the lesson here. We're gonna get as far as we can, and then we'll probably finish up some of it on Monday. I'm hoping to get you a majority of Monday to work on a worksheet.
Whoa. Is this gonna be a lot of notes?
Yeah. Okay, so let's just remember what polar coordinates are. Okay, remember, don't feel like you have to write everything down. A lot of this is what do you need to remember. All right, so polar coordinates. Okay, this is the coordinate plane that you're going to see. Polar coordinate is given in the form r comma theta, where theta is the angle in standard position, and r is how far you move from the origin along said angle. Okay, I know it is written as r comma theta, but I find it to be easier to draw the angle theta first and then move out r.
It's true. These are first notes of this. I'm excited. It's true.
Well, yeah, yesterday we did some good work down. Oftentimes you will see measurements of the special angles, pi over 3, pi over 4, pi over 6, pi over 2 angles, but it could be anything. You'll probably see radians more than degrees, but it could be either. Right? We'll do a couple practice coordinates here once you feel that you've written everything that you need to down. Good. Okay, so 3 comma pi over 2. We are first going to rotate to pi over 2, and then we are going to move 3 tick marks. Three pi over 2. Is that a question?
No, I was just doing the action.
Is that what I did?
Yeah. Can we do math aerobics for this? Yeah, it's like math aerobics. Okay.
We need to all do together.
I don't see it working well. So help me out. 1 comma negative 3 pi over 4. Rotate to negative 3 pi over 4. And then, where would we move? Forward 1?
Yeah.
All right, negative 2, 5 pi over 6. Where's 5 pi over 6? Okay, and then we would move backwards. 5 pi over 6, and then we would move backwards 2. Okay, negative r means we are going to move backwards. Okay, we can also express our coordinates in an infinite number of ways. Okay, negative 2, 5 pi over 6, we could also express as 2, 11 pi over 6, or 2, negative pi over 6. Okay, or negative 7 pi over, or negative 2, negative 7 pi over 6. Okay, lots of different ways we can do that.
What was the polar coordinate created? Why was it named? Why was it even a thing? Yeah, that's what he's asking.
Okay, there are some graphs that only work in polar coordinates. Okay, because it's based on rotation as opposed to horizontal vertical movement. Okay, those growth curves we can only do in polar coordinates because we're rotating as we're creating. Okay, it's kind of like, did you guys ever do those spirographs?
Yes.
Is that what it's called?
Yeah.
Like, so you have like all of those little turny things in the picture.
I had that. I had that.
Okay. It's like a childhood staple.
Yeah, the kids at the daycare have no idea how to use them, and they always break them, and I'm like, no.
Okay, let's talk about how these are graphed. Okay, so as we rotate from 0 to 2 pi, we can calculate different r values, okay? So, in this case, if theta is 0, what is our r value? What? 0? Okay. If theta is, where did I go next? Pi over 6. What is the r value?
4, right? That's just 4. Radical 3?
Okay. So, when we rotate pi over 6, we're going to go out to radical 3, which is like 3.5-ish. Okay, what about pi over 4? That's a nice one. So pi over 4, we're going to move out 4. What about pi over 3? Yep. And at pi over 2, we're back to 0. So what's happening is we keep rotating and finding r values. Here we are going to have flowers. Okay, what you're going to find happening next is when we go to 5 pi over 6, we're going to get negative 2. Wait. Yeah, right. Negative 2 radical 3. Agree? Disagree?
Agree.
Okay, so then we're going to kind of go through the same thing here. And then you know, because you've seen these before, we're eventually going to get this shape. Okay? If you were to put your calculator in both radian and polar mode, and you plugged this in, you would watch that curve be drawn in the manner that I just did. Okay, they're going to start at 0, and they're going to go through all the way to 2 pi, finding each of those r values step by step by step by step. Okay, is that an efficient way to graph? No, especially when you know nothing about polar coordinates. So we're going to look at different characteristics of the equations and what their graphs look like more towards the end of class, which will also bleed into Monday's lesson. Okay, we're just going to kind of see how far we get in the time that we have. What I want to more focus on today is how to change from polar to rectangular, rectangular to polar, both coordinates and equations, because that will also help you here with area and arc length and whatnot. Okay, so let's think about this. Here I have a coordinate xy. And how do we move to get there?
We go up y over x.
So we go over x and up y. Okay. What happens with polar coordinates? We rotate theta and then we move out r. Let's talk about some relationships here. How do we relate x, y, and r together?
X squared plus y squared equals r squared.
Grayson. inverse tangent of y over x is theta?
Isn't that just tangent theta equals y over x?
Yes, it is. Okay, that's probably more what I'm inclined to do, but if you like using the inverse tangent better, you go for it. Okay? You all have personal preferences, and we're kind of at the point where you can make those. Okay? All right, what else?
You.
What do we know r and theta? How do we find x and y?
Let's make the equation.
What's the sign ratio?
Let's just sign it.
Y over r? So y equals r sine theta. Cosine of theta, x over r. So x equals r cosine theta. Those are the four equations you need to have in the back of your mind when we are converting from one form to another. Okay? Which, at this point, I mean, we've used equations like these often enough. Hopefully those won't be too strenuous to remember. Our easiest conversion is when we have a polar coordinate and we want a rectangular coordinate. Go ahead and write down our polar coordinate of -2, 5 pi over 4. Okay, what did I tell you about x? So x is r cosine theta. What does that equal? Negative what? So what does this equal?
Square root of 2.
We wrote down y equals r sine theta. So r sine theta, same thing. So radical 2, comma radical 2. Now, Peter, is this a very accurate point to plot by hand?
No.
No. However, rotating to 5 pi over 4 and moving backwards 2 tick marks, is that accurate?
More so.
Yes, it is.
Did you
Okay.
really get
What?
Did you really get 5 pi over 4 then?
I might think that you would.
Yeah, what makes one more accurate than the other?
Well, we have, like if we have two of our grids, right, we have a polar grid that has all those special angles marked for us, already measured out.
I thought you were drawing those.
Yeah.
I don't know that number.
I was gonna say it's pretty hard to find 5 pi exact.
It'll be measured out for you. But do you see any grid marks that out by radical 2? What?
Could make it distance on the graph.
That is true. That is very true.
Yeah. Based off of that.
It's running.
All right, this is the coordinate we're going to convert now. -3, -3. We need to find r, we need to find theta. What would you like to find first?
R.
And how are we going to do that, sir?
Let's just do x squared plus I squared equals r squared.
Sorry, got excited. Wrote the wrong number.
Oh.
I'm excited this week.
I do like your, well, one of the things you wrote down. No more calling it a day. I appreciate that one.
See how long that lasts.
All right. All right, theta. How do we find theta?
Tangent of theta equals
So the tangent of theta equals 1. Be careful. Are we going to choose pi over 4 as our angle? Why not?
Because
it's in the first one.
Because pi over 4 is in the first quadrant, this angle is in the third quadrant. So we want 5 pi over 4 as our angle, so that the coordinate is in the correct quadrant.
That pi is different. I've never seen that.
Never seen one.
3 looks like there's a
It looks like a pie over nothing. But a bad pie. Like you made extra one.
What did you guys talk
I thought she wrote pie, but then she made another line and I was really confused.
Have you ever seen the octopi?
No.
about?
Man. God, I think there's one missing.
1, 2, 3, 4, 5, 6, 7, 8. It's not octopi.
But this is octopi.
It's octopuses.
All right. Now we're going to work on equations. How do we convert equations from rectangular to polar and back and forth?
That question cost us $2,000. Oh, that should be it.
But you've never won.
I quit. I lost today on question.
Okay, now, do we have any direct substitution for r? Well,
Yeah.
in terms of x and y.
Yes. You get plus or minus.
I think we do one more.
R equals radical x squared plus y squared.
So what do you do about that cosine theta?
Always the answer. Let's try.
Just
Substitution.
That's a nasty substitution.
Oh, wait, is it?
I see.
Oh, R equals radical
I can almost see.
R cosine squared.
I look at this, right? That's close. What does the right side mean? It needs an r, right? Are we allowed to multiply both sides by a number? Oh. X squared plus y squared is negative 8x. Okay? Okay? We can complete the square pretty easily, right? What completes our square? 16, yeah. This is a circle with center 4, 0, with a radius of 4. I will tell you that it's a lot easier to graph this circle in polar form because it's just to the left of the polar axis with a diameter of 8.
So what are we doing converting it?
Oh, no, thank you.
It's down
Thank you.
here.
Its diameter is 8. You don't see what happened?
I don't get how you get the top one.
So I multiplied both sides by r to get r squared. So I
I
can,
don't really use that information. I don't know, I was looking at the x equals r cosine theta.
okay.
Why is the
It didn't.
diameter?
Well, if we look at this, the radius is 4, right?
Okay.
But if it's in this form,
I was thinking radius.
this gives us our diameter. Okay. We could have r equals -8 sine theta, and it would be a circle below the pole with a diameter of 8. Yes, Peter?
Where did you get -8 next one? R cosine theta equals x.
Yeah.
Yes.
I will tell you that the more practice you do, the better at this you will be. This is what that circle looks like. Okay? To the left of the pole, because it's negative cosine, 8 gives you the diameter. And we'll talk more about those specifically. All right, let's go the other way. Okay, how are we going to convert this to polar form? Do we know what x is in polar form?
R cosine.
Yeah.
Do we know what y is in polar form? Now, if we have a rectangular equation, I don't really care what it looks like particularly, as long as it's something recognizable, line, circle, parabola, blah, blah, blah. If you have a polar equation, if you can, I would like you to solve for r. If there is not an r, I want you to solve for theta. So, in this case, we are going to solve for r squared.
Wait, couldn't you, like beforehand, if it's cosine theta, sine theta, use like one of those rules instead?
So you're saying here go r squared.
It would be, I think it would be 1/2, and you could have sine 2 theta.
So then r squared would be 8 cos secant 2 theta? Is that right?
I think so.
If either one I would accept. I'm not going to force you to use that identity, but if you recognize it, go for it. Okay. Now there are some special graphs that I will ask you to be able to recognize, like lines and circles, and then obviously we'll get into the rose curves and limaçons. Okay.
You have to say limaçon, like it's comfy.
Miss Crumpy says it way better than me. I called it limacons forever.
Oh boy, she got mad at us for that.
Did she?
Limacons.
Limaçon. Okay, I want to first talk about symmetry though. I'm a big fan of symmetry. I don't like things that are asymmetrical. Okay? It took me a long time to part my hair on the side. Grew up parting it in the middle. It was symmetrical. But then that like wasn't cool, so I had to part it on the side. I don't like that. I don't like clothes that are like they hang lower on one side than the other. Can't do it. I bought it.
Those clothes exist.
You've never seen like a shirt like that a female wears?
So you just wanted them? No.
Like
We
the
don't
bottom.
have it.
That's a good example.
I should have a good idea too.
That is a good example.
I would work on
Okay.
Next Friday, kindergarten.
I like symmetry. Okay, so let's talk about symmetry. If we have x-axis symmetry, if r comma theta is on the graph, what else would be on the graph?
Negative R.
Not quite.
R negative theta or negative R.
You're right, r negative theta.
Yeah.
If you think about rotating here versus rotating that negative same direction. Okay. All right, what about y-axis symmetry? If r theta is on the graph, so is
Negative R.
negative r, negative theta. You could also say r pi minus theta, but that's probably not what you're going to think of, in my honest opinion. Okay. If we have origin symmetry,
That's the one I was thinking.
origin symmetry.
For infinity.
If r theta is on a graph and it has origin symmetry, then there is also which coordinate?
Negative R theta.
No, yeah, negative R.
Negative r theta. You could also say r theta plus pi, but you're probably not going to think of it like that. You're basically just adding pi. Or rotation. Okay, so let's talk about a couple special graphs. I think we'll just talk about lines and circles, and then we'll save uniforms and rose curves for Monday. Okay, so first of all, if you have theta equals a number, like theta equals pi over 3, that is a line through the pole. Okay? This line, theta equals pi over 3. Its slope is radical 3, which kind of stinks to graph unless we're in polar form, and then we can just make a line through the angle pi over 3. Okay? There are also you can make a vertical line or a horizontal line, right? Let me see which one's first here. Okay, vertical lines, rectangular form, x equals a number, right?
Yeah.
Okay, well, if x equals a number, we know x is r cosine theta. Rearrange it, well, r cosine theta equals a, and we have a vertical line. Now, you are typically not going to see r cosine theta equals a. Remember, I just told you I want things solved for r. So in that case, you would see r equals a secant theta. That's a vertical line through a. Okay, so what does that mean about y equals, yep. We're going to use b, so b cosecant theta. Okay, in our last 5 minutes, we're going to talk about circles. I'm going to go rogue here. I'm going to do my own thing. First circle, R equals A. What does it look like? The circle around the origin. Oh, that's pretty terrible.
One day you made a really good one, and we get the same thing. We're just gonna install it. Which we could.
Yeah, today was not that day. Not that day. Okay, so R equals A. That means the radius is always A. So we have a circle where the center is the origin. Radius A. Okay, R equals A. Radius is always A. All the time. Okay? All right. Then we have R equals A cosine theta. That's what we talked about in that example. Do you have a question?
Yep. Can our graphing calculators change to the polar form? Can they draw a circle?
Yes.
Yeah. Okay, here's what we were talking about earlier. If you have R equals A cosine theta, you're going to have a circle to either the right or the left of the pole. And A is now giving you the diameter, because that's how far we are from the pole. And that's what A gives you. Now, how do we know whether it's to the right or if it's to the left? Positive to the right, negative to the left. If we change the cosine to sine, we're now talking about a circle with diameter A, either above or below the pole. I want you to be able to recognize these two different kinds of equations, not only for graphing purposes, but if you have to convert and you already know what it is, it'll help you a little bit, right? You know what you're getting to. Okay? But being able to see these and graph them is going to be very beneficial when we go to find area of the circle. Well, not area of the circle, but eventually, like, I will give you a circle, you'll need to know where it is, and I'll give you a rose curve, and you'll have to find the area of the overlap or something. Okay. All right, so your homework can be found where?
Gold sheet.
On the gold sheet. It is a book assignment, but do not worry because on Monday you will have a worksheet.